Okay, so we're still solving quadratic-like equations, but in this video we're going to talk about equations that don't factor. All right, and so we have an example here, 4 cosine squared theta minus 3 equals 0, and that doesn't factor. So one technique when you have something like this is to extract the square roots. Okay, and that just means to isolate the square and then take the square root. All right, so let's do that using algebra. First, adding 3. We'll have 4 cosine squared theta equals 3. All right, and then dividing by 4, we get cosine squared theta equals 3/4. Okay, once you have the square isolated, you then take the square root of both sides. Don't forget the plus or minus. And here we get cosine theta equals plus or minus square root of 3 over 2. Because the denominator here is a 4, so square root of 4 is 2. Okay. So we were able to get down to cosine theta. That's our variable. We have two solutions here. We have cosine theta equals negative root 3 over 2, or cosine theta equals positive root 3 over 2. All right, and we can solve each one of these like normal. All right, so let's do this one. We'll go through the reference angle theorem. So looking at that, I know theta hat is going to be equal to cosine inverse of square root of 3 over 2. And you can do it on the calculator, but that's one that we've memorized. And when I do that, the reference angle here is actually 30 degrees, right? Cosine of 30 degrees is root 3 over 2 in quadrant 1. Oh, yeah, speaking of quadrants, that's what's next, right? So here we have negative. Cosine is negative in Q2 and Q3, right? Those are x values. X values are negative in Q2 and Q3. And then for this one, we're going to have two solutions, one in Q1. Right? Cosine is positive in Q1, and also cosine is positive in Q4. Right? We know the reference angle. And so in Q1, the angle that we want is actually equal to the reference angle. And so right away, we know 30 degrees plus 360 degrees n is a solution to the original, right? You can plug that in and see if you get 0. In Q4, the angle that we're looking for is 360 degrees minus the reference. Right? And so in this case, 360 degrees minus 30 degrees is 330. Right? Plus the 360n. And those are the two solutions where, well, infinitely many solutions where the cosine is positive. All right, so let's move over to where cosine is negative. It has the same reference angle. So in Q2, we're looking at 180 degrees minus the reference. Right? So in this case, 180 degrees minus 30 degrees is 150 degrees. And I'll tack on the 360n, and that's the solutions there. Q3, theta equals 180 degrees plus the reference angle. Okay? In this case, 30 degrees. And so that gives us, what, 210? Plus 360 degrees n, and this has sort of a solution in each quadrant, right? And you can plug all these in, 30 degrees, 150, 210, whatever, into the original and see that you do get 0, all right? Okay, next we're going to talk about quadratic that doesn't factor, but it's a trinomial. So let's first think about algebra. When it doesn't factor and you're trying to find the two solutions, remember you have the quadratic formula. So you're going to have to memorize that. Ax squared plus bx plus c equals 0 is a quadratic. Has two solutions given by the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a, right? And so there's the two solutions you get using the quadratic formula. In algebra here, you could see a is 1, b is 3, c is 1. And so if I plug into the quadratic formula, I get negative 3 plus or minus square root b squared. So 3 squared minus 4 times a, which is 1, and c is 1, all over 2a. All right, and so when I do that, I get negative 3 plus or minus square root. And so 9 minus 4 is 5, all over 2. All right, and there's the two solutions, the plus and the minus. All right, we're going to do the same thing here, because we have a quadratic trigonometric equation, cosine squared plus 3 cosine theta plus 1, which is this exact same problem as this one, except the variable isn't x, the variable is actually cosine theta. And so using the quadratic formula in the exact same way, we have a is 1, right? B is 3. These are the coefficients. C is 1. And instead of x equals the quadratic formula, cosine theta is going to be equal to negative b, which is negative 3 in this case, plus or minus square root, right? 3 squared minus 4 times a times c, all in the square root, all divided by 2a. And so I can see here we get cosine theta equals negative 3 plus or minus square root of 5 over 2. All right, just using the quadratic formula, we were able to solve for cosine theta. Okay, now we actually have two solutions, the plus and the minus. So let me separate that because we're not done. Right? Negative 3 minus square root of 5 over 2, or cosine theta could be equal to negative 3 plus square root of 5 over 2. Okay? Now, it's kind of hard to work with the exact values on these problems. You can if you want. But what I'm going to do is get these on a calculator. Right? And so when I do it on a calculator, I get cosine theta is approximately negative 2.6180. And then for this one, when I do negative 3 plus square root of 5 over 2 on a calculator, I get approximately negative 0.3820. Okay? And these are ratios, so do notice that I did round off to 4 decimal places. Okay, now from here, what we're going to want to do is work through the reference angle theorem. Right? So we have values. So notice here, if I did do, let's say the reference is going to be cosine inverse of the absolute value, 2.6180. When I do that, make sure I'm in degree mode, notice I get, what, 2.6180, right? When I hit enter, I get an error. Because remember, cosine is a ratio between 1 and negative 1. And so the reason is, right, 2.6 is too big, right? And so that means when you get an error, there's actually no solution to that, right? You have to have a ratio between negative 1 and 1. You have to have a fraction. So we will be able to get a solution on this one. So what I'll do is come off to the side and I'll say the reference angle is going to be equal to cosine inverse of the absolute value of that. So 0.3820, right? And when I do that on a calculator, I get approximately 67.5 degrees. All right, and so we come back to here, cosine is negative in Q2 and Q3, right? So Q2 answer, and we're going to have a Q3 answer for this factor. All right, so in Q2, we're looking at theta that we want is going to be 180 degrees minus the reference. So 180 degrees minus the 67.5 degrees. The theta that I'm after is going to be approximately equal to 112.5 degrees. And then I'll go ahead and tack on the 360n. So there's infinitely many solutions there. And then in Q3, the angle that I want is going to be 180 degrees plus the reference, right? So 180 degrees plus that 67.5. The theta that I'm after is going to be approximately 247.5 degrees, and then I'm going to tack on the 360 in there. Okay, so there we have it. Here we got solutions in 2 quadrants. Remember, this one was too big, so that didn't contribute any solutions to the solution set. And so what does that mean? Well, if I plug these values in to the original, right, you should get 0, or approximately 0, because we do have round-off error. All right, so moral of the story. You can use the quadratic formula on these trig equations that don't factor. Okay, I already know the video is getting long. Let's do one more for completeness sake. I want to do one with sine. All right, and so this is a quadratic. You can tell because it's squared, and it's got 3 terms, right? It's a quadratic trinomial, and it doesn't factor. So we're going to use the quadratic formula. A here is 2, B is negative 1, and C is negative 2. Okay, So the variable here is sine theta, and so we'll say negative b, right, plus or minus square root b squared, so negative 1 squared minus 4 times a is 2, and 4ac, so 4ac, so a is 2 and c is negative 2, all over 2a. Okay? And so that says sine theta then equals 1 plus or minus square root. 1 plus 16 is going to be 17 inside there, over 4. All right, so from the quadratic formula, we got this ratio. Okay, so let's break that up. We have sine theta equals 1 minus square root of 17 over 4, right? Or sine theta equals 1 plus square root of 17 over 4. And so from here, what I want to do, like I said, it's hard to work with these exact ratios, so I'll do those on a calculator. Right? When I do 1 plus square root of 17 over 4 on a calculator, I get 1.2808. And then when I do 1 minus square root of 17 over 4 on a calculator, I get negative 0.7808. Okay, so we should be able to solve these little trig ratios. This one should be doable, but let's look at this one. If I do theta equals sine inverse on a calculator, I see that I do get an error, right? So what does that mean, right? Again, the ratio here is 1.2, and that's, sine ratios have to alternate between negative 1 and 1. 1.2 is too big. So that's what that means when you get an error. And so that just means there's no solution for theta. Right? That factor doesn't contribute any solutions. But you can see over here, this is a number less than 1, so I should be able to do this on a calculator. And so what I am going to do is go off to the side and look at the reference angle, and I'm going to do on a calculator, I'm going to do sine inverse of the absolute value. So positive 0.7808. And so on a calculator, let's do that. Right, sine inverse 0.7808. And I get approximately 51.3 degrees. All right, so that's my reference angle. And we know sine is negative in Q3 and Q4. Right? Sine is a y. The sine depends on the y value. So y values are negative in Q3 and Q4. And in Q4, the angle that we're, in Q3, the angle that we're after is 180 degrees plus the reference. So 180 degrees plus 51.3 degrees. The theta that we get is 231.3 degrees plus 360 degrees n. Right, so the infinitely many answers there are terminating in Q3. And here in Q4, we're looking at theta is going to be 360 all the way around minus the reference. So 360 minus the 51.3 degrees. Right, the theta is going to be 308.7. And then I'll tack on the 360n. Infinitely many solutions terminating in Q4 using the quadratic formula. All right, and that was one for sine. All right, great.